Hello everyone. Am I audible? Am I audible to all of you?
Yes.
Yes.
Okay, okay. Let's wait for 2 minutes more so that other can also join.
Hi, am I audible? Sorry, I joined late little bit.
Yes, you are. Yeah, good morning.
Thank you, thank you.
Okay, everyone. So let's start the session. Okay, so yesterday we were talking about K-means clustering, and basically today we are going to study the algorithm whose name is hierarchical clustering. Hierarchical clustering. See, basically this algorithm also works same as the K-means clustering. Okay, same. But the technique is a little bit different. Now, see, there were some drawbacks in the K-means clustering, as we have already seen. Some problems are creating while we are performing or making the model, okay, or making the groups or the clusters, okay. So due to which it was not able to perform that well. So that's why researchers applied some advanced techniques and some kind of mathematics and created an advanced feature of clustering, which is what which is we call hierarchical clustering. And now from its name, we understand that this is a hierarchy-based algorithm. So it's created a hierarchy. Hierarchy means like from top to bottom, from top to bottom, or bottom to top. We have two specific methods in this. Okay, in terms of hierarchy. Now, as I told you, we have some drawbacks. So let's discuss the drawbacks. First of all, let's say this is the advanced version of k-means clustering. K-means clustering, and it is doing the same thing, but slightly the technique is different. And we have some drawbacks with k-means. We have some drawbacks. Now, what is the drawbacks? What are the drawbacks? So drawbacks, somewhere the problem is to define or to identify number of cluster, means n cluster, to identify the cluster, means the value of k. See, if you don't know your data very well, it's really hard and difficult to decide it. And sometimes it may be failed to make the perfect cluster. Okay, and sometime with the problem of loop, uh, the the clusters may changes again and again. Okay, the position of the data points will be changed. Sometimes it happens. Okay, so the problem is to identify the clusters. Now, the second problem, uh, like k means assumes that clusters are circle, are circular, basically circular, but actually it is not. So the main problem is to define the structure of the cluster. Okay, so it makes the cluster like okay, and k means cluster makes the cluster like this. Okay, but it has to be like this. And it has to be like this, but actually k means actually it plot like this. Okay. So the main problem is to define the structure of the cluster. Now, the third main problem is it can not handle the outliers. The third number is it can't handle the outliers. If we don't remove them, let's say, suppose we have some data points like this. When we draw in the form of scattered form, and we have some data points like this. Okay. So in terms of outliers, there may be some outliers. See, these are the outliers. Why? Because mostly the data points occur in this area, but these are some data points which are totally apart from this area. So that means somewhere these are treated as what? Outlier. So this algorithm also consider these outlier as the data points. So it will means algorithm also consider these data points, but these outliers basically these outliers are data points. So researchers made some uh, have some applied some spatial techniques and some mathematics, and they created an advanced version of clustering that is called hierarchical clustering. Hierarchical clustering. It means it works on the principle of hierarchy, or you can say tree-like structure. It is a method of grouping data points by creating a nested sequence of cluster. Now let's understand the concept of clustering or hierarchy. What exactly means that? See, uh, let's say we have 200 data points. Okay, the size of our data set is 200. Okay, so total 200 data points we have. So where to start? The first step. So algorithm will understand or identify these 200 data points as 200 clusters. Okay, so initially algorithm uh, takes these 200 data points as 200 clusters. Okay, so initially we have total 200 clusters. That is equal to the data points. How many data points is equals to total number of clusters. Then it find the nearest cluster which has some similarity. Okay, so let's say so with this method, all clusters come together with 2 data points. Okay, for example, these data points we have. So this data point, like these data points. So this data point will come together and it will make a single cluster. Like this, now tell me, if you have 200 clusters initially, then how many clusters after these connecting with together? 100, right or not? If two clusters are come together, then how many clusters we have remained? 100 or not? Tell me, guys,
Yes,
that I can
100.
understand.
Yes,
100,
100.
right? And then again, these 100 clusters will come together and it will make 50 clusters. Then again, these 50, then 25. Okay, and then somewhere these will be 12 cluster, then 6 cluster, and it will go continue until it will not make a parent cluster. Parent cluster means a single cluster which covered all the clusters. Okay, so this is your parent cluster.
Is
Now,
that
what is the
means that
concept?
we are is that means that we are dividing all the clusters into half or
So we are basically we are not dividing, we are grouping clusters with each other with the help of distance. If the distance is minimum with in between two clusters, it will come together and it will make a single cluster. Okay.
okay. Okay. Okay.
So basically, then again in find the nearest cluster having similarities. Okay. Now, what happens? It will make a tree-like structure, and the tree-like structure called dendrogram. And this basically this dendrogram helps you to identify the optimal number of clusters. That how many is optimal number of clusters as suitable for our data set or for our model. Okay. So as you know that in k-means clustering we have a elbow method, right? And in hierarchical clustering we have a dendrogram method. First we create a dendrogram, then we will identify with the number of clusters, how many clusters is suitable or what is the optimal number of clusters that we have to define for our model. Okay, so this dendrogram helps to identify the optimal number of cluster. In k-means, if noted, note in k-means we have elbow method, and here we have dendrogram. First we create a dendrogram, then we will identify what is the optimal number of cluster. Now, basically, while we creating the tree-like structure or dendrogram, it follows the rule. The, the rule name is basically not the rule. Uh, the question is, the biggest question is how to make the distance between two clusters. How to find? To find the distance between two clusters, and cluster means data points. Okay, find the, you can say, minimum distance. Minimum distance. Now let's understand this. For example, we have a data. Data like 1, 4, 5, 8, and 10. Okay. Say 9 we have. Okay. So it basically makes the proximity, with the help of proximity distance matrix. It follows the proximity distance matrix formula. Now how it created? So first of all, I will create a matrix. First of all, I will write the data points like 1, then we have 4, then we have 5, then we have 8, then we have 10, then we have 9. Now, the same line, I'm writing 1, then comma 4, then 5, then 8, then 10, and then 9. Okay. So what is the difference? 1 minus 1 is equals to 0. What is the difference of from 4 to 1? That is 3. Then 5 to 4, that is 5 to 1, that is 4. Then 8 and 1, 7. Then 10 minus 1 is equals to 9. 9 minus 1 is equals to 8. Similarly, 4 minus 1, 3. 4 minus 4 is equals to 0. Then 1. Then 4. Then 6. Then 9 minus 4 is equals to 5. Then 4. 5 minus 1 is equals to 4. Then 1. Then 0. Then 3. 5. Then 4. Here 7. 4. 3. 0. 2. And 1. Again 9. 10 minus 4, 6. 5. And 2. 0. Then again 1. Mm, 8. 5. 4. 1. And 1 and 0. Now look at this matrix and tell me what is the minimum difference between two data points. The minimum difference
0,
is,
0.
see, we don't minus the same data points. See, these are the real data points. 1, 4, 5. Total, how many data points we have? 1, 2, 3, 4, 5, and 6 data points. So I can see the minimum distance is 1,
1.
10, and 9,
0,
right?
0 is not called the minimum distance.
See, 0 means we are subtracting the same data points. See, 9 and 9. So that's why the 0 is
To
called 0.
other. Okay, with reference to other.
Yes. So with respect to other data
That
point,
is
what is
1.
the minimum difference? That is 1, right? So 9 and 10. So these are the two data points, 10 and 9, and these are the two data points. So we can create one cluster with this, like this. Okay, so this is your first cluster. So I will write 10, comma 9. This is your first cluster. Now again, then the second two data points, which has the minimum distance.
It is 2.
4 and 5. That is 1. Right or not?
Yes.
Saurabh?
Yes. Yes.
Okay. So like 4 and 5. So these are the two data points and these are the two data points. So how can we make it? Now, how many data points we have? 4 and 5 are the minimum distance. So 4, comma 5, and then comma. Then, now what is the minimum difference? 4 and 5, and then 8. So basically, these two data points. Now this is a single cluster. So we can say 4, 5, and 8 as the minimum difference. The difference between it says 3. So I can say it will combine like this. So now how can I write here? 8, comma 4 and 5, and then this. Now we have a difference of 2. Actually, I did some mistake. Okay. Not 5 and 8, but we have 10 and 8, right? We have 10, 9, and 8. So from 8 to 10, we have the minimum distance of 2. Okay. And this is 2. So the matrix will look like this. Like this. Now I can write here comma 8. This is your third cluster. Now it's time to compare with 8 and 5. Okay. So I will be writing this one thing. Just write like this: 4, comma 5, and comma 8. This is your fourth cluster. Now I will combine this whole cluster to 1. Okay, I will combine this whole cluster to 1. So it will be like this, comma 1. And it will combine all this cluster. Okay, so the matrices look like this. Now tell me if you have any confusion in this matrix so that I can continue with the dendrogram. Basically, how can we create a dendrogram with this type of matrix? Means if you are understanding the concept to define the distance matrix, then you can understand how these things are working. Any question?
I have a question.
Oh, yes, yes.
In the first iteration, we chose 9 and 10. Why did
Mhm.
not we, in the first cluster itself, why didn't we choose 8 and 9?
8 and 9. We can take 8 and 9. See, it's totally up to you. I have created like so that I can arrange within a manner. Otherwise, if I create in like 8 and 9, so that 10 will be in the middle. So that's why I have taken at 10 and 9. It totally depends upon the data set. Okay, you can also create like this.
Okay.
Okay, you can
Thank you.
take at a 9. You can also take like 5 and 4 also. Okay, in the initial phase.
Yeah. Yeah. All right. Thanks.
Yeah. Now, with the help of this matrix, I'm going to create a dendrogram. So how the dendrogram is creating? Find it. So the first cluster was 10 and 9. So I can write 10 and 9. And the distance is 1. This is your 10. Now again, we have a cluster that is 8. And the distance is 2 with compared to 10. Okay, so this is 2. So it will be like this. Now we have 4 and 5. Okay, so now we have 4 and 5 data points. And the distance is 1. Will look like this. And it is connected with 8. So this is your complete one cluster. We don't have any 3 cluster here or 2 cluster here. Now it is converted into single cluster with 8, 9 and 8. So it has a one cluster. So it will be connected with 8 to 4 and 5. Now we have one more single data point, that is 1. So the whole cluster is connected with single. Now tell me if you are understanding this concept. So basically, that was C1 cluster number 1, and that was C2 cluster number 2. Okay, and we have cluster number 3, and that was cluster number 4. That is cluster number 5. So this is your final cluster. Clear, everyone?
Yes, yes.
Okay. So basically, we have two concepts. As I told you, if this is a hierarchy-based technique, so like hierarchy means we can say the hierarchy should be top to bottom or bottom to top, right? So we have two methods. We have two methods or concept. The first one is agglomerative clustering. In hierarchy clustering, basically we have two methods. The first one is agglomerative clustering. So agglomerative means aggregation. Aggregation. When we are working on like continuous data or some kind of very messy data, then we apply agglomerative clustering, and the other one is divisive clustering. And they are following the same concept of dendrogram. So now divisive clustering means dividing the data points from top to bottom. Okay. And this is creating from bottom to top. So basically, this is the example of agglomerative. But if I talk about divisive, so it will look like this. For example, we have 10, comma 9. So this is your final cluster. Then it will be divided into some parts like here. Okay, okay. Like we have data points 1, 5, 4, 8, 9, 10. Like we have data points. So this is your final, or we can say parent cluster. So it will be divided into two part. Two part means like 5, 4, 5, 4, and 8, 9, and 9, 10, and 1, comma 10. Then again, these data points divided into 2 points, like 5 and 4, and 9 and 10. Then again, the 8 and 9, and 1, comma 10. Again, it will divide it into two parts, 5, 4, 8, and 9. So it will be continuously until the minimum data point we have not obtained. So it was started from these whole data points, means the parent cluster, and it is divisible. It is dividing by continuous with some data points which has a minimum distance. Okay, but basically we are not using so many times. Like we don't use usually we use agglomerative concept. We don't use divisive clustering. Okay, so that's why I explain very well about agglomerative, not for divisible clustering. But sometimes if your data is very simple, and if your data is very uh, basically not hard to understand, so that we will apply divisive clustering. Okay, but usually we apply agglomerative for better clustering. Okay, now tell me if you are getting this point.
Yes, yes. Divisive, agglomerative.
Divisive agglomerative, right? Now, the basically sometimes it uses Euclidean distance formulas. Distance, and mostly it uses distance matrix. Okay, okay, now understood this? And one more thing. Okay, I'm not explaining right now, otherwise you will be get confused. Now let's go for hands-on. Okay, now create a new good web See, it is asking create in a shared folder because I have already shared this folder to you guys, right? So I am going to create this folder and it is also sharing with you also. Okay, so if you have this SAF new batch 8 to 10 whole like a folder, so that whatever I am creating in this folder, whatever the files I am creating in this folder, it is also sharing with you. So I think no need to share. It already sharing with you. Okay, but yeah, don't worry. After the end of the class, I will always, like always, I am sharing with you in the chat box, right? But you can see you can find in your SAP new batch 8 to 10 folder. Okay. Now we are using the same data set. Okay. We are using the same data set that what you were using customer.csv. Okay. I told you to compare with spending score and age. I think. Have you tried this?
Nup, nup.
At least you have to try. Okay, just try it after the class, whatever, whenever you find time. Okay. Class. Done this much? What we are doing, we are plotting the scatter chart to see the distribution of the data points. Now, what the data points we are taking here? We are taking annual income and spending score. Okay. So here I am taking a very short break here. Now you have to do one thing, guys. Uh, just solve this question. Like plot the scatter chart. Okay, for annual income and spending score. But
Okay, just share this link, please, for this
yes, yes,
program.
yes, yes, yes.
Okay.
So like yesterday, I have created with Matplotlib, right? Now create with the help of Seaborn. I'm sharing this file in the chat box. Just it. Got it?
Yeah, got it. Got it. Fine. Thank you.
Done, everyone?
Yes, done.
Okay. Created with Seaborn or Matrocket?
I did it with Seaborn.
Perfect. What about others? Malaz, Andrew. What about you? Shikshita? See, the approach is same, but the difference is we provide X and Y coordinate in Seaborn. Okay. That is also very simple. Like with Seaborn, so SNS dot scatter and in parenthesis, I will provide X is equals to from DF. I want to apply annual income. We just copy it, Control C, and just paste here. And similarly, for Y coordinate, Y is equals to mm, from DF. I want spending score. So just copy this and just paste here. Okay, and simply PLT dot so whatever. Okay, PLT dot so. Scatter is not attribute. Oh, sorry. Scatter plot. Okay, see, this is spending score and this is annual income. Now, what I'm going to do is I'm taking in X variable, I'm going to define the data from DF. I want DF dot columns. I want annual score. I mean annual income. and I want now what we are doing here. Now it's time to plot the dendrogram. So now we will plot dendrogram, which will predict the optimal number of clusters. So first of all, uh, we have a library called SciPy. Okay, SciPy. Import from basically SciPy, we are going to import hierarchy from the cluster. So scipy dot cluster, and from cluster I want hierarchy. Hierarchy. Okay, and just do one thing. Just take a uh, alias so that I can use this sort name while I'm writing hierarchy. So just take HR hierarchy. Okay, just run it. Now, what I'm doing here, I'm going to create dendrogram. So first of all, just define the figure size. So plt dot figure and fig size is equals to, I want 10 cross 7, and the title should be plt dot title. The title should be customers so data dendrogram. And de and o dendo is equals to, by applying hr dot dendrograms, and one more method that I want to apply here, that is hr dot linkage. So basically linkage, and in linkage basically we are providing the data set here. Okay, x, and the method should be ward. So basically the linkage determines how the distance between cluster is calculated in hierarchical clustering. Okay, so we are using ward. So basically it is ideal for compact and spherical clusters, sometimes not the circular, but somewhere spherical. Why? Because we have already seen here our cluster, whenever our cluster is being generated, that will be like spherical. See, it's not in the circular motion. That's why we are using ward. Now simply just run this. What happened? Hierarchy has no attributes. Dendrograms. Okay, it's dendrograms. See, the dendrogram has created.
Wow, super.
So actually, what I'm doing here, copy image. Now the problem is with the dendrogram, how can I identify the optimal number of clusters? What is the optimal number of cluster from this dendrogram? Now this is the main problem.
It is type of like looking like decision tree structure.
Yeah, tree structures. That's why the name is hierarchical. It has following some hierarchy.
Right. But this color codes are based on the type of the structure, cluster.
Yeah, it takes automatically.
Okay.
Okay. As for
But that
like
different color means the different structure, a different
yeah,
cluster.
the different cluster. Okay, see the orange one is whole one cluster. Okay, so it
Yes.
started from this data point to this data point, right? Let me
Right.
explain this.
So are the different colors used to signify that the clusters are disjoint, meaning they have no common data points?
Yes. So basically, the blue one is connected. This blue one is connected with this segment. Okay, this side, and the orange one. This line is a parent connection with these small clusters. See, basically it started from these clusters, then again for these clusters, then it is connected with these clusters, then finally this cluster is connected with this according to the distance. So this is what, this is your distance. Okay, the data points started from 0, 50, then 100, 150, 200. So I can say the distance of this vertical line, the orange one, this vertical line starting from 50 and end up to 260, I think. So 260 minus 50, that is 210. So the total distance between this cluster to this cluster, which is combined, which is connected with rest of the clusters. See these clusters, and that is what, 210. And similarly, the green color has a different cluster, and the red one also different cluster, and it is connected by the blue line, blue cluster. Okay, and the whole one is connected with all of the children clusters. Okay, child clusters.
Okay.
Now,
And
yes,
the in the example we just used absolute value between two numbers, but in here the distance will be calculated using Euclidean distance, right? Because this is a two-dimensional data, like they're taking two different columns. So each point will have two coordinates, right?
yes. That's why it is using Euclidean distance. Yeah, clear. Right. See, now the question is uh, to identify the optimal cluster. We have to follow some steps. The steps are, first of all, we find the longest vertical line from our plot. Okay. So, first of all, select the longest vertical line link in the dendrogram. And that are not highly crossed by other horizontal lines. Okay. So the long line indicates the larger difference or the distance between the clusters, mean the separation from each other. Right. Okay. Then once we find or select the longest line, then we have to cut the dendrogram at an appropriate height. At an appropriate height uh, horizontally. Okay. Then the line we cut or we can say count the bisect data points where the line cuts. Okay. Now let me explain it. Now just find out which one is the longest line, which one is the longest vertical line.
Looks like one of the two vertical blue lines.
Right? Blue lines. So that this blue line is the longest vertical line. And even I can also identify it. It is started from 100, right? Started from 100 and it goes up to like 400 or 390 approximately, right? 390. So 0 and then 9 and then 3 minus 1 is equals to, oh, sorry, 2. The distance is maximum here, 290. Is there any line which is longest vertical line here? Tell me. So we found that the blue one is the longest vertical line. Now, how can I cut here? Like I can cut from the, as I told you, we have to cut the dendrogram at an appropriate height horizontally. So like it will be, I am going to cut this dendrogram like this. And how many data points are there where it bisect to the next or other dendrogram or cluster? See, this is the bisect point, this one is the bisect point, and this one is the bisect point. So how many clusters we have? Total three clusters we have. Agree? Now, don't worry, we are taking some more examples to practice on how to cut the dendrogram and how to identify the longest vertical line. Okay. Okay, see, like just take this. Now tell me which one is the longest vertical line here? This one, right or not? Saurabh, people, agree with this?
Yes.
I'm confused between that line and the one starting from letter I, the blue line.
Uh,
That's
the
like
letter I, this
I.
one, right?
Yeah. So,
See,
yeah.
basically, it is starting from the initial data point. Okay, this is your individual cluster. So we cannot take this individual. Why we are choosing this? Because this is connected with two data points. Okay, and this basically connect with blue cluster, the whole cluster, which conclude all the data points. So we are not identifying only the cluster. We have to find also that the clusters are interconnected or not. If we are taking this, then we will break the rule of dendrogram, cutting the dendrogram. Okay, so that's why we are taking yellow line, this one. See, and when we cut horizontally this, see how many data points? One, two, three, and four. So total four clusters we have. Agree? Or any suggestions?
I agree.
Now let's take one more example. Now find out the vertical line and just cut the dendrogram. Quickly, tell me which one is the longest vertical line.
It looks like one of the two blue lines on the left, upper
Mhm.
left.
These, right?
Yeah, but I'm confused exactly where should we cut those lines? Do we maximize the number of clusters or do we minimize the number of clusters? Because depending on where we cut them, we have different number of intersection points.
See, sometimes this is the game of hit and trial. Okay, so we have now two options. Whether we can cut from here or we can cut from here. So if we are taking the upper line, so we are getting 1, 2, and 3. And if we are cutting from here, so we are taking 1, 2, 3, and 4. So sometimes we have to apply this like first we apply 3, then we apply 4. Okay, so some when we are building the model, it's not mandatory that we are taking the optimal number exactly for the first time. Okay, sometimes it happens. So we have to change the number by number. Okay,
Okay.
now just apply these things. That how can we apply the number of cluster? Just go for hands-on. I think this is sufficient. And rest of the time, whenever you find some time, just practice on that. Okay.
Yeah, okay.
So in k-means clustering, we also find three clusters, right? If you guys remember. Above dendrogram, we found three optimal clusters. So from sklearn dot cluster import agglomerative clustering. Let's run it. Now clusters is equals to, just do one thing. Just take it like as AG or AC, agglomerative clustering. Okay. So with the help of AC, I'm going to pass some parameters. So like n number of clusters and clusters is equals to 3. And we are taking metric is equals to Euclidean. Okay, Euclidean, and linkage is equals to Ward. Let's run it. Now labels is equals to clusters dot fit and predict. Fit and predict what? The whole data set. Just run it. And labels. See, these are the labels. So 0, then 1 and 2. Total, how many clusters we have? 3 clusters. Now we will plot the graph to show these clusters. Now what I'm going to do is just copy the code, or, or you can write. Why? Because I want to pass C is equals to like plt dot scatter, and from X annual income and from X I want spending score, and C is equals to labels, and plt dot show. Uh, See how the cluster is created. Okay, or if I go and check and apply some 5 in this, give me a minute. And if we cut the dendrogram from, like, which is the second longest vertical line here? This is the second vertical, second largest vertical line. It started from 50 and it's end up to 260. So total the distance is 210, which is the second highest vertical line. Okay, longest vertical line. And if we cut the dendrogram for here from here like this, so total how many clusters we have? Like one, two, sorry, not from here. Give me a minute. 1, 2, 3, 4, and 5. So here with this line, we have 5 clusters. Okay. Just try this with number of clusters is equals to 5. So what I'm doing, just copy this, Control C. When applying 5 clusters, clusters 2 is equals to, and cluster is equals to 5. Just run it. And just copy this. Clusters 2. Now just run it. See, now we have 5 clusters like this.
Yeah, this aligns pretty well with, I mean, I made the test with the same two columns yesterday with k-means,
Mm-hmm.
and when we set number of clusters equal to 5, this
Mm-hmm.
aligns. I mean,
Look
this
like
is
this, right?
almost similar to what I got yesterday.
Yes, yes. So see, as I told you, these two algorithms are working the same thing, but the technique is different. Something are different apart from that k-means clustering. The hierarchy clustering follows the different rule. Okay, so
Yeah,
it's totally depend upon the data. When it is required for hierarchy clustering, then we apply hierarchical clustering, and especially in hierarchical clustering, we apply most of the time we apply agglomerative, but in sometimes we apply divisive clustering, and like if it is not required, then we apply k-means clustering. Okay, so we have a different approach. So if you are working in a company and if you are working on the project, and the team is trying hit and trial to apply hierarchical clustering or k-means clustering, so that they will find that this one is best for the model, so you can choose that model, right? So again, this
yeah,
is all about the experience. Okay, if you are doing by continuing by any project and doing the same thing, a lot of things you will learn from the projects when you enter in the IT field, and you will you are working on any kind of real time projects and in the team. So like your data engineer told you that we have to apply hierarchy, and you are saying that I don't I want to apply k means, so then you will mix up these things and then you will hit and trial and then you will find the best thing, right?
yeah.
So this is all about the concept of hierarchical clustering. And in the next class, like in the next week, we will starting PCA. PCA. So PCA stands for Principal Component Analysis. Okay, and that is the concept of dimensionality reduction. Whenever we working on the data set, the main problem is we have a lot of dimensions. A lot of dimensions means a lot of features. Features means a lot of columns that sometimes they are unwanted columns. We don't want these columns, so we have to make the feature engineering. Feature engineering or feature selection means to make your data very well about modeling. Okay, so yeah, we will discuss in the next class this PCA concept. But if you find some time, just read out the PCA concept so that you will be easy to connect all these things. Okay.
Okay.
Just keep refreshing and updating the file I have shared in the chat box, name as hierarchical clustering. So you will get all the updated codes which I have written here. Or if you want once again, then I will share it. Tell me. And I am sharing this file also. Got it, everyone? Confirm it.
Yeah, I got the file.
Yes,
Done.
yes. Me too got the file.
Perfect. Okay, then see you in the next class. If you have any doubts, so please ask me.
Okay. Bye. Bye for now.
Okay. Bye
See you
bye.
next week.
Thank you.
Next week we are starting deep learning also.
Right after the PCA concept, and we have one more concept that is yeah, the final one is PCA. Then after we will jump to the deep learning part or the AI part. Okay, so where we learn
Okay.
the neural networks.
Yes.
Okay. Yeah.
Okay, fine. See you. Bye bye.